Chapter 8.2 Notes, Graphs of the Other Trigonometric Functions, page 2, with sound. So here's the graph again for reference. We just graphed it. This one goes out a little more. We show the asymptotes at 3 pi over 2, negative 3 pi over 2. The fact that tangent is periodic means this repeats. Okay, so let's take a look at what we've got. Our domain is all real numbers except where x is some multiple of pi over 2. So we're going to write it this way. Pi over 2 plus n pi or k pi. I tend to go back and forth. I believe the textbook uses k. N is an integer. Okay, now, if you've already looked at the text, you may see it like this. X is not equal to pi over 2 times the absolute value of b plus pi over the absolute value of bk, where k is an integer. Means the same thing, but that b is going to be what we do with the period. So as we modify the period, right, our asymptotes are going to change. Our range, our y values, negative infinity to infinity. Our x-intercepts, look at where we see them. I see them at negative pi, we'll label that here, 0 pi, 1 pi. So our x-intercepts are at multiples of pi. Or x equals n pi, where n is an integer. Our y-intercepts, remember that's what happens when x equals 0. Only y-intercept we have is that point 0, 0. Our vertical asymptotes occur at the same place we have those holes in the domain, those odd multiples of pi over 2. Right, so 1 pi over 2, but not 2 pi over 2, which would give us pi, and that's a 0. Okay. In general, the equations look like I wrote the domain above. X equals pi over 2 plus n pi. N is still an integer. You got to make sure you include that. We can't assume anything. The zeros are located at multiples of pi. So let's talk about other reference points that we can use as we graph the tangent. We are going to use our odd multiples of pi over 4. Feels like a really weird way to say it. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, because that's where our tangent is plus or minus 1. A whole lot easier for me to use, especially if I've got some sort of multiplier out front, than looking at some of these square root of 3s or square root of 3 over 3. I really don't want to play around with having to graph those. Okay. Does the tangent of x have a maximum value? We can take a look at this. This shoots up towards infinity, so no, it doesn't. Does our tangent of x have a minimum value? No. So this is different than sine and cosine, where we were bounded by -1 and +1. Is tangent an even or an odd function? Just like it was when we defined it as a function, it's still odd here, especially because it's the quotient of an odd and an even function. That's going to be odd. Okay. General form of the tangent function. It kind of looks like the general form of the sine and cosine. The numbers mostly do the same thing. Okay. Little change. So A is now our vertical stretch or shrink. There is no amplitude because this shoots off to infinity, right? So we don't have a maximum value or a minimum value. Pi over b is the period. A little different than sine and cosine where it was 2 pi over b. If you look up here at our graph, this graph repeats every pi. Okay, so the period here is different. C over b is still the phase shift or the horizontal shift. That's going to move us left or right. And again, that D at the end is our vertical shift. That is going to move our graph up or down.